Today's notes are on using the properties of exponents. The first property is the power of a power property, which says if you have a base raised to a power times the same base raised to another power, you can simplify it by keeping the base and adding the powers together. Example, this would have been if I had x squared times x cubed. I can simplify this by keeping the base and adding the exponents together, giving me a final answer of x to the fifth power. The next one is a power of a power property, which says if you have a base raised to a power raised to another power, you can simplify it by multiplying the exponents together. So if I have x cubed being raised to a power of 4, I can simplify it by keeping the base and multiplying the exponents together. The third property is the power of a product property, which is similar to the power of a power property. We're still going to multiply the exponents together. We just want to make sure that that m goes to both terms inside the parentheses. So for example, if I have xy squared, that 2 attaches itself to the x. It also attaches itself to the y. The fourth property is the negative exponent property, which says if you have a negative exponent, it can become positive by flipping it to the denominator. Likewise, if it was already in the denominator and it was negative, you could flip it to the numerator. So if I had x to a power of negative 3, I could simplify it by putting it in the denominator. The base stays the same, the exponent stays the same, only it becomes positive. The next one is the zero exponent property, which says anything raised to the 0 power is equal to 1. That could be an exponent raised to a 0 power, or it could be a number raised to a power of 0. Both equal 1. The quotient of a powers property says if you have a base raised to some power divided by the same base raised to a power, you can simplify it by subtracting the exponent in the numerator by the exponent in the denominator. So x to the fifth power over x cubed simplifies to x to the power of 5 minus 3. You always do your subtracting in the numerator. So this subtracts to x squared. The last one is the power of a quotient property, which says if you have a quotient raised to a power, that power gets distributed to all terms inside the quotient. So if I have x over y squared, this simplifies to x squared over y squared. Let's go down and look at some examples. They want us to simplify these problems using positive exponents in our answers only. So looking at example A, 2 to the power of 3 raised to the power of 4. This is the power of a power property. So I'm going to keep the base and I'm going to multiply the exponents, which gives me 2 to the power of 12. Then because this is a number or coefficient instead of a variable, we can simplify this again. You actually want to do 2 to the 12th power, which gets you an answer of 4,096. We're going to work down the left side of your page here. The first property we're going to use is the product of powers property. For example C, I have the same base. So I'm going to keep the base, and this time you are adding the exponents, which gets us negative 5 to the power of negative 2. I'm then going to use the negative exponent property to get a positive 2 as an exponent instead. Notice that the negative in front of the 5 is still there. Flipping it to the denominator only changes negative exponents. Negative coefficients are okay. When you plug negative 5 squared in, if you have to use your calculator, make sure you put parentheses around the negative to get your answer of 1 over 25. We're going to use the product of powers property again here with example E. It has the same base, so we're going to keep the base and add the exponents. So I get 4 to the power of 6, which gives me 4,096. And the last one, G, we are going to use the quotient of a power property. I have the same base in both the numerator and denominator. So we're going to keep the base and we're going to subtract the exponent in the numerator by the exponent in the denominator. Make sure that you don't lose that negative, because it was minus a negative. It really turns into 7 raised to the power of negative 2 plus 3. Which is 7 to the first power, which we can just write as 7. Please try and do the examples on the right side on your own. Example 2 wants us to continue by simplifying the expression. This time it's a combination of coefficients and variables that we have to simplify, but the exponent properties work the same way. So for example A, the first thing I'm going to do is make sure that that 2 gets distributed to everything. So we end up with r squared over s to a negative 10 from negative 5 times 2. Then using the negative exponent property, I'm moving just the s to the numerator. The r does not move, it does not flip because it already has a positive exponent. Example C, I want to start the same way by making sure this 2 gets attached to everything. So I get x squared y to the 4th over x cubed y to the negative 1st. Then, now that I have the power of 2 on the outside of the parentheses distributed in, I can continue to simplify the x's and the y's. So I'm going to use the quotient property. So I'm going to take 2 and subtract it by 3 for the x's. For the y's, I'm going to have 4 minus a negative 1, which gives me x to the negative 1st power, y to the 5th power. And then because of the negative exponent, I'm going to use the negative exponent property to move just the x to the denominator to give me my final answer. We're going to look at 2 more examples together here, example E and example G. When you have coefficients like 5 and 20, they simplify the way that you think they would. 5 over 20 simplifies to 1 over 4. And then I can continue on looking at the exponents. So I have a base of x, and I'm going to use the quotient property to have 3 minus 2. For y, I have 9 minus a negative 2. So I get x to the 1st power, y to the 11th power, and this is over 4. It is up to you whether or not you want to write out the coefficient of 1. For our last example, G, because you have one fraction multiplied by another fraction, you have two options. You can either simplify each fraction first and then multiply them together, or you can multiply across the fractions and then simplify. So first though, I want to start by making sure my exponent of 3 here gets distributed to everything. So I get 3a c cubed f cubed over 8bc a squared f to the 4th. That 2 is getting distributed. On the other side, I'm going to leave the numerator alone, and in the denominator, I'm going to make sure this 2 gets distributed to everything, including the 3. So 3 squared gives me 9. Everything else, I'm multiplying the exponents. So I get a squared, b to the 4th, c squared, and f squared. Next, I'm going to go ahead and multiply it across. So 3 times 6 gives me 18. I am now adding the exponents. So 1 plus 1 gives me a to the 2nd power. Then I'm going to go in alphabetical order. There's nothing for me to combine the b's with, so that stays the same. C, I have 3 plus 1, which gives me c to the 4th power. And there's nothing for me to combine the f with, so that's going to stay f cubed. We're going to do the same thing in the denominator. 9 times 8 gives me 72. I'm going to add the exponents on the a together to get a to the 4th. Then we get b to the 5th power, c cubed, and f to the 6th power. Now that I have one fraction, I'm going to go ahead and simplify. 18 over 72 simplifies to 1/4. And I'm going to take exponents in the numerator and subtract them by those in the denominator. This is going to give me a to a power of -2, b to a power of -3, c with a power of 1, f with a power of -3, and this is over 4, which we can then simplify, getting rid of all of the negative exponents. The only thing that's going to stay in the numerator is the c. The a squared, b cubed, and f cubed all move to the denominator. Go ahead and try the examples on the right side of your paper on your own.